Alright, in this video lesson we are going to learn about factors and prime numbers. We will be learning what factors are and how to list them using factor pairs, and we'll try to learn the first 10 prime numbers and prime factorization, all of this. So let's begin. Factors are basically divisors that leave no remainder. Let me give you an example. Let's say 6 is divisible by 2. If you divide it, it goes 3 times, 3 2s are 6, remainder 0. So we say that 2 is a factor of 6. Okay, we can also divide 6 by 1. It goes 6 times, remainder is 0. That means 1 is a factor of 6. Also 6 is a factor of 6. It goes once, remainder is 0. So factors are divisors that leave no remainder. Okay, we can list the factors of 6 in factor pairs. So factors of 6 can be written as 1 and 6. This is the first pair of factors of 6. Then check if it is divisible by 2. Yes, 6 is divisible by 2. Write 2 here. Then divide 6 by 2. 6 divided by 2 is 3. So we'll list them here. Is there any other number in between? No. That means we can stop here. We can say that these are the factors of 6. So this way, using factor pairs, we can list the factors of a number. Okay. And the numbers that have only 2 factors are known as prime numbers. Okay. So let's say, what are the factors of 2? Factors of 2 are basically 1 and 2. Okay. Factors of 3, 1 and 3. Factors of 5, 1 and 5. Factors of, let's say, 17, 1 and 17. Okay. So there is no number in between that can divide 17 and leave no remainder. So these are the factors of 17. This way, if a number has only 2 factors, those are known as prime numbers. Okay. First 10 prime numbers can be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are the first 10 prime numbers. You can notice that 2 is the only even prime number because all the other even numbers are divisible by 2. Okay. Similarly, all the multiples of 3 are not prime because 3 is a prime number. It can divide all the other multiples of 3. Let's say 6 is divisible by 3, 9 is divisible by 3. So those are not prime numbers because of this. Similarly, multiples of 5, multiples of 7, we can discard all of them. Between 1 and 10, 2, 3, 5, 7, these are the only prime numbers. Between 11 and 20, you have 11, 13, 17, and 19. Between 20 and 30, you have 23 and 29. This way you can learn all the other prime numbers as well. But for the time being, you can try to learn the first 10. Okay, this will come in handy when you try to do prime factorization. Okay, prime factorization means you're trying to find the prime factors, prime number divisors of a number. Okay, so if the question says break a number into the product of its prime factors, let's say in 60, we can write 2 times 2 times 3 times 5. These are all prime factors of 60. It can be written as index form. This is the index form. So 2 times 2 is 2 squared times 3 times 5. When you multiply these prime factors, you'll see that it's 60. 2 squared 4. 4 times 3 is 12. 12 times 5 is 16. Okay. So we can use 2 methods to find out the prime factorization of a number. One method is called factor tree method, which is basically you try to find out any 2 factors of a number. Let's say 1 and 60 first of all. Okay, then 60 can be written as 6 tens are 60. Then 6 can be written as 2 times 3. 10 can be written as 2 times 5. So this way, if you just have a look at the last numbers, you'll see that there are 2 times 2 and 3 times 5 here. Okay, so using factor tree, you can find the prime factors of a number. Another more popular one is the division method. We don't quite use the factor tree method. The division method is you write 60, then you put a mark like this, check by which prime number you can divide. Let's say I can divide this by 2. So I'll write 2 here as the divisor. 60 divided by 2 is 30. Okay, then you put a mark again. Can you divide 30 by 2 again? Yes, write 2 here. 30 divided by 2 is 15. Can you divide 15 by 2 again? No, 15 is not divisible by 2. Okay, because it's an odd number. Can you divide 15 by 3? Yes, 3 5s are 15. So let's write 3 as the divisor here. 15 divided by 3, you get 5. 5 is divisible by 5 only because it's a prime number. So 5 by 5, you get 1. So you keep on doing this until you get 1 here. And you can list all the prime factors from here, from the left. You can write 60 equal to 2 times 2 times 3 times 5. Okay, or in the index form, if you have same numbers multiplied together, you can write there are 2 numbers. You can write 2 to the 2, which is 2 square, times 3 times 5. When you multiply them, as I said, you'll get the same number, so you don't need to multiply. So 60 can be written as 2 square times 3 times 5, product of its prime factors. So this process is prime factorization. Let's have a look at a few more examples.